Hello guys, welcome back. In today's video, we'll see about algebra. So what is algebra? Algebra is branch of mathematics that deals with variables. So we would have dealt with constants, right? So constants are just the numbers. Say 2, 4, 8. And then we have equations like 2 plus 2 equal to 4. This kind of equations. Now using variables, we can define like use the alphabets A, B, C, also the capital letters or some symbols, and then we can write equations using them. So these kind of equations. So A plus B equal to 2A. This kind of equations we can write. So this is about algebra. We would have also seen this earlier while solving equations and also in geometry, right? Coordinate geometry, we would have saw the x-axis and y-axis, equation of line. So everywhere we use variables and it falls under algebra. So we define in algebra what is called as function. So function is a kind of one-to-one mapping, or it's a kind of relation between input and outputs such that each input has one and only one output. So we can take an example. Let's say I have some numbers in the input 1, 2, 3, 4, and output I have some more numbers 2, 7, 8, 9. Let me include another number 16. So each input should have only one output. Let's say 1 is mapped to 2, 2 is mapped to 8, 3 is mapped to 4, and 4 is not mapped. So if 4 is not mapped, this has 0 output. But that is not a function. So for function, every input should have one output. And can it have more than one output? That is also no. It should have one and only one output. So only one. But they both can correspond to the same output. So this is possible. So both 3 and 4 correspond to 7. But the definition says only about the inputs, right? Input has one and only one output. So the outputs may be same. So this set of inputs is called as domain. And this set of all outputs, including whichever is not mapped, is also called the codomain. So codomain includes 2, 7, 8, 9 and 16. Okay, and we define something called as range. So range is nothing but only the outputs which are mapped. So just 2, 7 and 8. So you may ask why we need to define codomain and range, right? Sometimes it may be useful when we are taking, for example, function of a function. So let's say f of x maps from some domain to some codomain, and g of x also maps from some domain to some codomain, right? So this codomain, since f of g of x, so this codomain should again be the domain of f of x. So then it becomes useful. Or when we take inverse also, inverse of a function, let's say f inverse of x, then this codomain becomes useful. Okay, so this is about functions. I'll give some examples. Say f of x is equal to x square. So this f of x represents the variable, so x square. So f of 1 will be 1 square, which is 1. F of 2 will be 2 square, which is 4. And f of 3 is 3 square, which is 9. So if we just try to plot it, we'll have 1, 2, 3 and so on. And in the codomain, if you also have 1, 2, 3, 4, 5, 6 and so on, we have 1 mapping to 1, 2 mapping to 4 and 3 mapping to 9 and so on. So next we will see some basic forms of representing the functions. Basic forms of representing a function. So first one is analytical. So this is the example we saw, right? Writing it in this form, in equation form, x square f of y is equal to y cube, this way, f of x is equal to x square plus x plus 1. So this is analytical representation. The second method is tabular form. So tabular form is for each x we give some values of, for some of the values of x we give the values of f of x. So for 1, let's say x square itself, we have 1, 2 we have 4, 3 we have 9 and so on. So for this you also have the tables for trigonometry, right? Trigonometry and logarithmic tables. So these are examples of tabular forms. So the third form is very important. It is the graphical form. So this is how we draw it in the graph, right? We have x and y axis. We take y to be some function of x. Then we plot it. For example, y equal to x square, we have the points, right? So we have 1, 1, 2, 4, 3, 9 and so on. So we can plot it here. So this is 1, 1. So 2, 4, 3, 9 and so on. And then we can plot it this way. So this is the graphical form and it will be very useful in solving questions. So we'll see it when we try to solve the questions. Okay. Next we have what is called as even and odd functions. So even functions are nothing but if you flip the value of x to minus x, then the function remains same. So this also means that they are symmetric about the y-axis, right? So this is a positive x-axis, x side, and this is negative x direction. So when there is an inversion in size, they are still equal. So whatever is there this side, the same will be present this side also. That is what it means. It is symmetric about the y-axis. This is the y-axis. So what about odd functions? So f of minus x is equal to minus f of x. So whatever we have this side, on the positive side, it will be reflected in the third quadrant. So this is first, second, third and fourth. So whatever is here, the same thing will draw but reflected on the x-axis. So it will be on the negative side. That is what it means. So it is like a reflection about this axis. So this is reflection about y-axis. This is reflection about some y equal to minus x kind of axis. Okay, so this is the definition of even and odd function. To see some examples, f of x equal to x square. So what will be f of minus x here? Minus x whole square, which is nothing but minus 1 square into x square. Minus 1 square is nothing but x square itself. So this is equal to f of x. Hence it is an even function. Odd function, f of x equal to x itself. So f of minus x is equal to minus x, which is nothing but minus f of x. So if I just want to draw it graphically, let's take f of x square. So 1, 2, 3. Okay, 1, 2, 3, 4. This is the origin. 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2. So we have 1, comma 1. Minus 1 also corresponds to 1. Minus 1 square is 1. Then 2 square is 4. Minus 2 square is 4 again. And 3 square will be somewhere here, 9. Minus 3 also is 9. So you can see the symmetricity, right? So the function comes like this. So it is something like this, right? Okay. So this is called as a parabola. This representation is parabola. This form of the graph. And then we have f of x equal to x. So So 1, 2, 3, 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. So we have 0, comma 0. Here also the 0, comma 0 point, right? And 1, comma 1, 2, comma 2, 3, comma 3. Minus 1 maps to minus 1, minus 2 maps to minus 2, minus 3 to minus 3. So we have a straight line for y equal to x. This is a straight line. And it's passing through origin. And you can see it is symmetric about this axis, right? So it is a odd function. So not every function needs to be falling in any one of these. So these are some special kind of functions, that's all. So for example, if you take the exponential function, so in the graph we'll have something like this. At 0 it will be 1, and less than 0 it will be less than 1 and tends to 0, and for greater than 0 it approaches infinity. So you can see it is not symmetric along any axis. So this is neither even nor odd. So these type of functions also exist. So next we have inverse of a function. So one basic idea is inverse of a function is also a function. Okay, so if we have this kind, right, f of x equal to x square, so we have minus 2 and so on, minus 1, 0, 1, 2 and so on, and this side again we have minus 1, 0, 1, 2, 3, 4 and so on. So 0 maps to 0, minus 1 to 1, minus 2 to 4, 1 to 1, 2 to 4 and so on, right? So we are saying inverse of a function is also a function, right? So inverse is nothing but the reverse mapping for every y. For every f of x we need to find x. So if f inverse is the inverse function, f inverse of f of x should give you one value, right? But if you see, if we take the reverse mapping, for 4 we have two reverse mappings, 2 and minus 2, right? And again for 1 if you take, you have 1 and minus 1. So this cannot have an inverse, because the inverse does not satisfy the function's definition. So f of x equal to x square does not have an inverse. Suppose there is also another one number which is unmapped. If you see 2 and 3 are unmapped, right? But when you take the reverse, they should at least be mapped to one number, right? So in that case also, if we are considering only the integers here, so 2 and 3 are left unmapped. If we consider the real numbers, then we'll have root 2 here mapping to 2. So that time it might be possible, but again, because of this negative real numbers and positive real numbers mapping to the same, we will not have the inverse. And also, if you see, the negative numbers is not having any corresponding mapping for a square function under the domain of real numbers. So two conditions should satisfy, right? So the first condition is all outputs should be unique. So all outputs should be unique, right? So this is called as one-to-one mapping, and such kind of functions are called one-to-one functions or just one-one functions. So they are also called as injective functions, injective mapping. So what is injective mapping? For every input there should be one unique output, right? So 1 2 3, let's say 4 5 6 7. So for every input there should be one unique output. So it does not say anything about output having an input or not. So the output may not have any input at all, but for every input there should be one unique output. Only it should be mapped to one output, and the output should not be mapped to any other input. Okay, the second condition we saw it, right? There should not be any elements left. So that constraint, this constraint is imposed by the second conditions. So all output should have at least one mapping. To input. So in other words, the codomain is equivalent to the range, correct? So these type of functions are called onto functions or surjective. So if a function satisfies both of these conditions, then we will be satisfying all the conditions for inverse to exist. So inverse exists if the function is 1 1 and onto. Okay, one simple example is f of x itself, right? So what is its inverse function, do you think? So here if you have the numbers 1 2 3, it maps to 1 2 3, right? So what will be the inverse? Inverse is nothing but the same, right? So f inverse of x is nothing but x itself. As another example, f of x equal to x cube. So if you consider all real numbers, then it is 1 1 and onto. X cube is 1 1 and onto. So f inverse of x will be nothing but x power 1 by 3. So if you take f inverse of f of x, so that is nothing but f of x power 1 by 3, and f of x itself is x cube power 1 by 3, which is equal to fx. So if g is inverse of f of x, then what do we have? G of f of x is equal to x, and f of g of x should also be equal to x, correct? So g is nothing but f inverse. These two conditions are satisfied, then it is g is equal to f inverse. So now we'll see some examples of how graphs of different equations. So first we will see some x equal to some constant. Okay, a is constant. So you should develop this skill of drawing graphs from the equations. Then only you will be able to visualize it quickly and solve the questions quickly. Some questions involve drawing graphs that rather than solving it numerically or solving it analytically. So x equal to a, what it means, for every value of y, the x is same. So this is some a. So any point you take, any value of y, x will be a constant. So this is the equation of x equal to a. So second, if some y is equal to b, y is equal to constant. So how do you draw it? This was a vertical line. What do you expect y equal to b to be? Right, a horizontal line, right, at b. So for every value of x, the y is going to be b. So then we can draw a line. So y equal to b is an horizontal line. So next is some y is equal to some kx. You see, y and x are proportional, directly related by a constant k. So in this case, what do we have? So we can write a table x and y. Some negative numbers. -2 we have minus 2k, -1 we have minus k, 0 we have 0, 1 we have k, 2 we have 2k, and so on. So 0 comma 0 is a point, then 1 comma k somewhere here, somewhere here. So we'll get a straight line, right? We'll get a straight line, and straight line is strictly passing through origin 0 comma 0. So that is this equation. So if k is greater than 1, how will the straight line look? So this will all be greater than 2. So let's first draw the equation y equal to x. So in that case, the slope will be 45 degree, right? This is y equal to x. So y equal to kx, k greater than 1, how will the line look? It will be steeper because y is more than x, right, on the positive side, and less than x on the negative side. So we'll have a steeper slope. So this k defines the slope, right, how steep the graph is. If k is less than 1, then we'll have this kind of slope. What happens if k is equal to 0? It's nothing but y equal to 0, right, if you substitute here. So this is nothing but the x-axis. So y equal to 0 is the x-axis. What about x is equal to 0? X is equal to 0 when k tends to infinity. So that will give you the y-axis. Okay. So with the simple y equal to kx itself, we can get these many different graphs for different values of k. So next is nothing but some shift kx plus c. So how do we define this shift in this graph? So let's say y equal to kx is this line. This is y is equal to kx. C is somewhere here, let's say. Should we take it on the x-axis or y-axis? If you see, when x is equal to 0, y is equal to c, right? So it comes on the y-axis. So if this is some c, we see that when x is equal to 0, y is equal to c. So this is a point on the line. And we know it is proportional to the slope is same to this line. So what you do, you just shift this line. So this line is nothing but y equal to kx plus c. If c is a negative number, then we'll have it here, right? So this will be y equal to kx plus c. For example, if it is minus 2, it will be passing through minus 2. Right. So if you see, this is intersecting x-axis at some point. So what do you think that point will be? How do you find this point? Yes, you substitute y equal to 0, because on x-axis y equal to 0, then you will have x is equal to minus c by k. So this point is minus c by k. What do you think this point is? If y is 0, x is equal to 2 by k. Okay, right. So this is nothing but you get a shift. So next we'll see y equal to 1 by x. So what you have 1 by x, if x is 0, y tends to infinity, right? And as x increases, y will tend to 0. So it just comes like this and goes to 0. So what is this point? When y is equal to 1, sorry, x is equal to 1, y is also equal to 1, because 1 by 1 is 1. Similarly, if x is negative, when x is tending to 0, minus from negative side, y will tends to minus infinity. So it comes from here. And as x tends to minus infinity, again it goes to 0. So it is something like this. Again this point will be minus 1 comma minus 1. Right? Suppose I want to draw a graph like this. Same thing, but it comes in the second and fourth quadrant. So what will it be? So it is just a reflection of this about the y-axis. So I want to put this side and this side. So we already saw if you want reflection about y-axis, we just need to replace x with minus x. So this will be nothing but y equal to minus 1 by x. So next we will see a parabola. So y is equal to x square. So this we already saw, right? So it is some graph like this. And it is passing through 0, 0. So it is passing through 0, 0. So its point will be 1, 1. And then it will be 2, 4. And this side it will be minus 1, 1. Minus 2, 4 and so on. So if you see, y is always positive because of this x square term. So if you want the square root function, y equal to square root of x. So then what you will have? So if you see, the square root of minus negative number is not valid. So the domain itself is restricted to only positive numbers, right? So at 0 you will have 0. So 0, 0. At 1 you will have 1. 1, 1. At 2 you will have root 2. So at 4 you will have 2. So 4, 2. So it is like this. Right? So this is for plus root x. Root x we always consider it gives only the positive value. If we want to draw y equal to minus root x, so it will be 0, 0, 1, minus 1, and then 4, minus 2 and so on. So if you see, it goes like this. So if you see the entire graph, right? So it is just this graph shifted on the from y-axis to the x-axis, right? So what do you think is this function? This x is equal to y square. Correct, no? So then y equal to plus minus root x. So that is what we have done. So if there is only one part, then only one part of the equation comes. One part of the curve comes. So this equation is also x is equal to y square. So then the parabola shifts to the x-axis. Okay. So what about y is equal to minus x square? So it will shift to the negative y-axis. And x is equal to minus y square, it will shift to negative x-axis. Next. So y is equal to x square plus some constant, let's say 2. So for this, the shape remains same because the dependence is still x square. But if you see at x equal to 0, y equal to 2. So this curve just shifts up. So it starts from here. So this curve just shifts upwards. So if x square minus 2, then it shifts down, right? It starts from this point, 0, minus 2. Right? So this is shifting along the y-axis if you add a constant. How do you think you will shift if along the x-axis? So you should take within x. x plus 1 whole square. So if you see y is equal to 0 at x equal to minus 1. The 0 point is somewhere here, minus 1 comma 0. And from here the parabola comes, right? So this is shifting to the left. So if you want to shift to the left, shift left by c units, then what you do in the equation, you replace x with x plus c. What about shifting right? Replace x with x minus c, because shifting right by c is same as shifting left by minus c. So they are equivalent. So similarly, if you see for y, this is nothing but y minus 2 is equal to x square. And we saw that it shifted top, correct? So replace y with y minus c to shift top. And replace y with y plus c to shift bottom by c. So this is shifting operation. So this will come very handy again. So you don't have to write each and every point of this equation to draw the graph. You can just shift it left or right or up or down to get the proper graph. So next, what if I want to shift both x and y? Then you just do the combined operation. If you want to shift y top by some c1, then we have y minus c1, and x to the right by c2, then we have x minus c2 whole square. So where will this start from? It will start from c1 comma c2, and it will go like this, right? So this will be the new parabola. So next, we already saw the exponential function, and before that we'll see y equal to x cube. So x power n, if n is even, then the function is also even. If n is odd, function is also odd. So y equal to x cube, 3 is odd, right? So this also should be odd. So one side it will have this kind of behavior, other side will have this kind of behavior. This y equal to x cube. So x power 4 will be similar to x square, right? But it will just be a little steeper. For example, if this is x square, so x power 4 will be like this. It will be steeper, right? Because y is having higher values for x greater than 1. What about x less than 1? It will have lower values, right? So 0 to 1, and here also we have 1. So in this region, 1 comma 1, if this is the y equal to x square, I'm just drawing one side. So for x less than 1, y equal to x power 4 will be less than this, right? And x greater than 1, it will be greater than this curve, x square curve. So this will be the curve. It will just copy on the left side as well, because these are even functions. And this point both will be same, 1 comma 1 is same for both. Okay, so next we will jump into the exponential function. So y equal to e power x. So at x equal to 0, what happens? It is 1. So this point is 0 comma 1. And as x grows, x is greater than 0, this one keeps growing, right? So e is some 2.3 something, some value. So it is 2 point something, I am not sure with this. So power x. So this number e is greater than 1. So this one keeps growing. So at x equal to minus infinity, it tends to 0. At x equal to infinity, it tends to infinity. Okay. Similarly, if you take any number y equal to a power x, for a greater than 1, you will get this same curve. What if a is equal to 1? So 1 power any power is same as 1. So this equation is nothing but y equal to 1, which is a horizontal line. What about a less than 1? So we'll see that. Let's take 1 by 2. So power 2 becomes 1 by 4. So at 1 by 2 power 0 is 1. So it goes like this, right? It just goes and decreases. So from 0 comma 1, when x increases, this decreases, and at x tends to infinity, it becomes 0. On the other side, 1 by 2 power minus 1, it becomes 2, right? So it keeps growing on the other side. So as x tends to minus infinity, a power x for a less than 1 tends to infinity, and as x tends to infinity, y equal to a power x for a less than 1 tends to 0. If y equal to minus a power x, so it will just be negative of this. So I'll just draw in these graphs negative of this. So this is 0 comma minus 1. Similarly, here also it is negative. This is 0 comma minus 1. Okay. And here a power minus x, if you see, is not related to a power x. So instead a power minus x is 1 by a power x. Correct? So here changing the minus sign, what I have told you, changing x equal to minus x, it will just be a reflection about y axis. So a power minus x will be this way. It will just reflect about y axis. Here also similarly you can draw. Sorry. Right? So that is when y turns negative and x we change from x to minus x. So next we'll see logarithmic functions. So y equal to log x. So this is nothing but same as telling log e power x. It is same as telling e power y, x equal to e power y. Okay. So what happens when x equal to e power y? So whatever is there, this curve, right, it will just shift to x curve. So we'll get something like this. So this is 1 comma 0. We'll get something like this, right? This is y is equal to log e x. So logarithm is by nature itself, it is defined like this. If x is equal to e power y, then y is equal to log ex. This is base. So we'll discuss more about logarithm in the next lecture. For now, stick with me with this thing. So for x equal to 1, log e1 is 0. So 1 comma 0 is a point, and as x tends to infinity, y also tends to infinity, but it is slower. Okay, if you see exponential, it grows faster, but log grows slower and still reaches infinity. When x tends to minus infinity, when x tends to 0 itself, if you see, y tends to minus infinity. So again, what is the problem here? It is only defined for positive x. Alright, so we usually define it as modulus of x. Again, why is it so? Because x equal to e power y. If you see, y equal to e power x, y was only positive. So when we take the inverse, logarithm is inverse of exponential function. So then we need to restrict the domain, right? Which is only the positive real numbers. So we can also draw like the sine and cos functions. Sin x, f of x equal to sin x. If you say this is restricted between 1 and minus 1, this x and y. So x equal to 0, sin x is 0, and when x equal to pi by 2 it reaches 1, and when x equal to pi it again becomes 0. When x equal to 3 pi by 2 it becomes minus 1. On the other hand, minus pi by 2 it becomes minus 1, and it oscillates like this. So if you see, it is an odd function. Do you see the symmetry? Sin x is an odd function. Then we will see cos x, cosine function. At x equal to 0, what is cos x? It is 1, right? This is the point. And when x comes to pi by 2, it becomes 0. When x goes to pi, it becomes minus 1, and it goes on. On the other hand, at minus pi by 2, it is again 0, and minus pi it becomes 1. So if you see, it is an even function. Okay, so I have covered this much. There are also other many functions like tan x and all other rest 3 trigonometric function. You can go and take a look at it, and also from the tables you can try to plot these values and see how the graph behaves. So it may be useful for you, right? Okay guys, I hope this lecture was very useful. We'll also see about logarithms and other rest of the topics in algebra in the later lectures, and then we'll finally solve some questions. Thank you. Bye.